Okay, so we are going to cover isomers. It is again very important concept for your JEE, NEET or state board also. Okay, so isomers is what? First we have to understand that isomers is nothing but when the same compound, okay, or same or molecule having same molecular formula but different structural formula are called as isomers. Okay, so I'm writing the definition first. When compounds have same molecular formula but different structural formula but different structure are called as, or structure, or instead structural formula you can write, are called as isomers. Are called as isomers. Understood what isomers means?
Yes, sir.
Okay. So first we have to understand example also. Suppose we have, I'm just writing butane. Okay. See, but represents the 4 carbon chain. So I'm writing here 4 carbon. Okay. So 4 carbon means like 1, 2, 3 and 4. Okay. And we know here that A and E represents all the carbon-carbon single bond. So we have represented carbon-carbon single bond also. But carbon have valency 4, means carbon is going to form 4 bond. So in order to fulfill the valency, we had to like combine hydrogen atom here. Yes, hydrogen atom here. So see here that first carbon is forming 3 hydrogen bond and 1 carbon bond, means its valence is getting fulfilled. But that center carbon, that one having 2 bonds only, so we will require 2 more bond. So here we have CH2, here also CH2, here CH3. Yeah, so this is the linear structure. So I'm just going to write formula for butane. So how many carbon we have? C4. So C4, and how many hydrogen we have? 4 2s
10.
are 8 and 2 10. So C4H10. Okay, H10 is the structure, formula for molecular formula for butane. Understood that?
Yes, sir.
Okay. See, before going to start, its isomeric form, I am just going to make you understand what is bond line structure is. Have you heard that bond line structure before?
Yes, you taught in 10th class only, right?
Yes. So it is very important to learn, because most of the time you will going to understand the bond line structure only. Okay, that's why in 11th and 12th to understand and to write a bond line structure is very important. See, this is nothing but the structure for butane, right? Is it, everyone? Keep replying.
Yes, sir.
Yeah. So can we write in condensed form, like not condensed form, but like CH3 chain structure, then we have CH2.
Yeah, that's the condensed form, I guess.
CH2 and CH3. Can we write that in this way?
Yes, we can write.
Yes. Okay. Now I'm going to write that linear structure into zigzag form. This is called a bit of dash structure, huh? Dash structure. Do remember the name. This is a dash, because instead of bond we are using dash here for all the bonds, so it is called as dash structure. This is called as linear structure.
Sir, I guess the first one is called the full image of the compound.
Yes, it is called a
and
dash
the
structure.
second one is called the compressed form.
Yes.
Form.
Yeah, but here in first structure we are no condensed form is not that. Condensed form is like CH3. We have CH2 2 units, so in bracket we had to write H2
Okay.
and here twice and
Yeah,
here
that's the way
CS.
of representing it. Yeah.
Yeah, this is the condensed one. This is the condensed one, and this is the linear structure. Okay.
Okay.
Yeah. Okay. So see that first one, we have used all the dash here. That's why it is called as dash structure. Okay. That one is dash structure. Okay. So from linear structure, can we write that CH2, CH3, CH2, CH2 in this way? CH3, then here CH2, then here CH2, and here CH3. Can we write that?
Yes, sir.
Yeah. So this is called as zigzag structure. Zigzag structure for butane. Now we are going to write only the bond line structure. So we are going to use bond between carbon and carbon. See, here we have, this is the first bond. So I'm writing as it is here. This is the second bond. So I'm writing as it is over here. And this is the third one. This is first, this is second, and this is third one. So third bond over here. Can we do that? Only bond. Understood?
Yes, sir.
Yeah. So this is called as beta bond line structure. Bond line structure. Okay, see, here we have nothing but the carbon. So all the corners and on the end point, okay, at the terminal region, we have carbon atom only. So can you easily observe 4 carbon here?
Yes.
1,
Yes.
2, 3, and 4. Yeah. So now think about that carbon atom. Here it is forming only one bond here, right? Only one bond with other carbon atom. So 3 valencies are remaining. So just you have to understand here. Here on that particular point, we have nothing but the CH3. Okay.
Okay,
Okay.
sir.
Yeah. Because if here we have carbon and it is forming only one bond over here, so we have 3 remaining valencies. So instead of 3 valencies, we have to use CH3. So if here we have nothing, that means we have CH3. Now so I'm writing here CH3. Now second one over here, see that carbon is forming 2 bond. This is the first and this is the second bond. Means 2 valencies are remaining. So here carbon will present along with 2 hydrogen atoms. So CH2 will present here. CH2 will present here. You are getting the point, no, everyone?
Yes, sir.
Yes.
So here we have CH3. Here we gonna have CH2. Here also CH2, and here again CH3. So this is, that one is called as bond line structure. Any doubt in bond line structure, how to form?
No, sir.
Okay, so now I am just asking one question for like different compound. Wait. Okay. What is it? Uh-oh. What is this then? What is it? What is here?
So it's a propane molecule.
Yes. So here we have CH3. Here we have CH2. And here we have CH3. I hope you understood, everyone.
Yes, sir.
Yeah.
Okay, so one by one, I am like asking the question. So first, for Samarth is done. Okay, second, Samastha. Samastha, na?
No, sir, my name is Samhita.
Okay, Samastha. Okay, so this
Samhita. Samhita.
Samhita. Okay,
Yes.
okay. Yeah, for Samhita, we have here 1, 2, and over here. This is single bond, no? Not double bond. Wait. Yeah, here. For that, you have to tell the structure like this. See, here we have CH3 beta, because only here the carbon, see, here we have carbon, here also, and at the center also. Okay. Now, can you tell me Structure for that?
Sir, may
Who name?
I? Amtar Rahman.
Yeah, yeah, beta.
Butane, it's CH3, CH2.
CH3, not CH2 beta, it is CSC. Here we have that
Okay.
carbon which having
Okay.
which have completed 3 valency. So here we will have only CH.
Oh, okay, okay.
Yeah. Then here we have CH3 and here also CH3. Okay?
Okay.
Easy
Okay.
or very easy?
Easy a bit.
Okay, okay. You will understand like after 5-10 example, you gonna tell all the hydrocarbons like this only for bond time. Don't worry. Third one. Third one is for Garima. You there, beta?
Yes, sir.
Okay, for that. It is for Garima.
So CH3, the first
CH3.
one,
Yes.
and then yeah, CH2,
Yes, CH2. Then
and then the next one is CH,
yes, very good. CH.
and then CH3 on both
CH3 and
sides.
here also CH3.
CH3.
Yes, very good. Garima got the point. Very good. Now, next. Fourth one is for who is left?
Me, sir, Aditi.
Yeah, Aditi is the sorry, Aditi. I haven't observed. Okay, okay. For Aditi, for this beta.
CH3,
CH3.
CH.
See,
Two.
carbon have only valency 4. See, just let me explain you where we have carbon. Over here, here also, here also, here also, and here, center also. So these carbon have completed all the 4 valencies, no?
Yes.
Means
Yes.
here only we're gonna have carbon.
Okay.
Yeah, and all the sides CH3 like this.
CH3 and CH.
Yes.
I got it.
Okay. Easy?
Yes, sir.
Okay. Next, for Samarth again.
Okay, sir. Yes, sir. So it's a cyclohexane ring, and
I'm starting from here.
okay. So that's a CH2.
Yes, CH2.
CH2 and the other 5 on its both its sides, the other 2 are CH2 and CH2. Then the
CH2,
next CH2, CH2,
CH2,
CH2.
CH2,
Then
and
the
here,
last one you see is a CH.
yes, here we have CH, yes.
And the next
Here,
bond is connected as only C.
yes. Here,
And all are CH3 is
yes,
left.
all are CH3. Very good. Okay, very good. Now, next again for Samhista. Next one is for you, beta.
Yes, sir.
Uh, for that,
Starting from where? Anywhere?
from here.
Okay, so CH3,
Yes, CH3.
then CH,
Yes, CH.
then CH3 again,
CH3 again.
and then CH,
CH.
and then CH3,
Yes.
and then down again CH3.
Yes, very good. I think you got the point
Yes.
for bond line structure. Very good. Okay. Again, one is for Amtu. I hope you are getting all the point, no, everyone?
Yes, sir.
Okay. So I didn't remember the number, but I'm just giving you the example. Uh-oh. Yeah.
Starting from where, sir?
From here in this side.
CH 3, 2.
Just go for valency beta. Carbon have completed two
Okay.
valency by two bonds, so only two is
CH2.
remaining. CH2. Yes. CH2. Then
CH2.
see, here we have 1, 2, 3, 4 bond completed by carbon, so only C.
Okay, yeah, it's okay. C. Then dot.
Here and here. Here.
CH3 and up CH3 and other
Yes.
side CH3.
Okay. Now here.
CH2. No, CH, only CH.
CH. Yes. Here.
CH2.
Yes. CH2. Here.
CH3.
Yes. Good. You got the point now. See, you always have to count number of bond. If you won't find more than 5 or more than 5. Okay, you may find like 3 or 2 sometime. Okay, sometime 1, sometime 2, sometime 3, sometime 4. If 4 are there, okay, means carbon is not going to form more bonds, so carbon will present alone. Okay, if 3, so carbon will have 1 bond with hydrogen, like this. If had 2 valence is completed, so 2 hydrogen will remain. If only 1 is completed, so 3 hydrogen will have to remain along with carbon. Okay, so this is the way you had to. So I was explaining about all these are nothing but the bond line structure. So we are just going to discuss about isomers for that first one structure called butane. Okay, so now we are going to understand example for isomers of butane. So here we have the butane, right? So you have to look only for the possibility by which we can have different arrangement having 4 carbon atoms. So this is the normal chain of butane, so it is called as N-butane. It is called as N-butane. But if I can think that particular carbon may be present over here, it is possibility, no? So can we write that also? So here we have 3 chain, like main chain of 3 carbon, and here we have another carbon. Okay, so for N-butane I can write CH3, CH2, CH2 and CH3. So this is the first structure for butane. Okay, for formula C4H10. Okay, so this is the molecular formula and this is the first isomer. Okay, and for that we can write structure like CH3, CH, here CH3 and here also CH3. Okay, so this is the another structure for butane. Okay, so this is the second isomer. Understood? So this is nothing but the difference between the main chain of the hydrocarbon. So it is again the isomer. Understood? So see here, now we are going to write the name for that also, name. So this is beta N-butane, we have already written here, N-butane or only butane you can write. Okay, and for that, okay, see, that methyl group is present on second carbon atom. So we had to write substitutions name first. So it will be 2 and name of the group is methyl. So it is 2-methyl. Okay, this is the main chain, and in main chain we have 3 carbon atom. So for 3 carbon atom we used to write prop, P-R-O-P, prop, and all the carbon present single bond. So for single bond we are writing A and E. So it is 2-methyl propane is the IUPAC name for second compound. So here we have normal N-butane and here we have 2-methyl propane. Okay, so these are nothing but the 2 different structure for butane and they have different properties. Okay, they have different physical as well as chemical properties like reactivity, their state, okay, is different also. See, in both the structure we have 4 carbon and 10 hydrogen. But still there is a difference in their structure, and due to difference in structure they have different property. So these two are nothing but the isomer of butane. Understood everyone what is isomer is?
Yes, sir.
Yes.
Yeah. So we have many types. but we have divided isomers into two main categories. First one is called structural isomers and other one is called as stereoisomers. So now we are going to understand the types. Okay, before that, I want you here to take a screenshot for whatever the part we have covered in isomer. Wait a second. Okay, so now we are going to understand about the types of isomer. So we have divided isomers into two main categories. Okay, first one we have structural isomers. Okay, number one we have structural isomers. Structural isomers. And number two, we have stereoisomers. Stereoisomers. Second type. Okay. So what is the basic difference between structural and stereoisomers that we had to understand? So I'm just going to write the definition. Any idea about what is the difference between structural and stereoisomers, Samar?
Yes, structural isomers consist of 4 parts. They are
No, I'm not asking the types. I'm just asking what is the basic difference between them.
structural means the specific. It is based on the structure of the compound.
And
The
stereo?
isomer according to its pattern and structures.
Okay, this in order to understand in a simple way, you just have to remember isomers. I'm just discussing about structural one. Okay, isomers which have isomers which have same molecular formula, but different IUPAC name. Or you can say IUPAC name also. Okay, are called as structural isomers. Samarth, very important, you have to remember that. Okay, they have same molecular formula. Molecular formula is the same, but they have different IUPAC name beta. Like we just gone through about butane. So what are the IUPAC name? One we have N-butane and another one was 2-methyl propane. Is it?
Sir, N-butane is not the IPAC name. That it's a common.
No,
name.
yes. No, not N-butane. It is like butane only. N only used in order to show the normal chain of butane. Okay. Otherwise, it is IUPAC one. But means 4 carbon and N means all the single bond. So butane is the IUPAC name. N is represent in order to show whether it is the normal chain or not. Okay. Okay.
Okay, sir.
Yeah. So butane and 2-methyl propane are the two different IUPAC name for C4H10. Okay. So what do you mean by that stereoisomers then? See, they are the isomers having same molecular formula as well as same IUPAC name, but different in arrangement, or we can say difference in their orientation. Orientation will be different. Okay, like suppose in case of butane only, here we have CH3, here we have CH2, here we have CH2, and here we have CH3. So this is the boat form, right? But if we will write that in such a way, like CH3, here CH2, then here CH2, and here we have CH3. So this is the chair form. So these two isomers comes under the stereoisomers. Understood? So this is nothing but the orientation, you can say, but it takes place between the double bond here. So instead of CH2, we had to write CH here. Okay, instead of CH2, we can write CH here. So here double bond and here CH3 like this. Okay, so they provide out the arises due to restriction in rotation here. So we have boat form and one we have chair form. So these are the two different isomers have different property, but IUPAC name for them will be the same. Is it? Samarth,
Yes, sir.
everyone.
Yes, sir.
Yeah.
Yes.
So what is going to be definition for that? Isomers which have same molecular formula, same
Same IUPAC name,
yes,
but differ
IUPAC
the
name.
position of their bonds.
Yes, orientation of molecule is different, that's all. Okay, but same molecular formula, same IUPAC name, but difference in their orientation, or difference in orientation of molecule, we can say difference in orientation in molecules, okay, are called as stereoisomers. Even in stereo we have two types, okay. One are called as like configurational, and other one is called conformational. Okay, this configurational cannot be synthesized in laboratory, okay, but conformational can be synthesized in laboratory, okay. And that configurational conformational isomers have like different types, okay. Like we have geometrical, okay. So instead of writing over here, I am writing here configurational, stereoisomers, okay. And second one we have, these are the types of stereoisomers. We have conformational, stereoisomers, okay. Understood, everyone?
Yes, sir.
Okay.
Yes.
Okay, sir.
So just take a screenshot. Done?
Yes, sir.
Yes, sir.
Okay. So I'm erasing that from here. Oh, they are of two types. One is called structural and stereo. Then we have configurational and conformational. We will discuss that later on. First, we have to discuss structural isomers here. Okay, see, structural isomers have 5 types. How many types we have, Samarth, for structural isomers?
So 5.
5 types.
Yes, 5 types. Number 1, we have chain structural isomers. Okay, if there is a difference in main chain, okay, that's we discussed over here in last example for butane, there is a difference in main chain, so it is called as chain isomers. Second, we have, this is the first one. Second, we have position. We will like cover one by one to all these types now, one by one. I'm just writing in short here only, okay. So position isomers means what? Suppose here we have like 4 carbons chain, and on first we have bromine, okay, on first we have bromine, but we can think that bromine can be on different position over here, okay. So this will be, there is a difference in position of bromine, is it or not? So due to which IUPAC name is going to change. Here we have 1 bromo or bromobutane, and here we have 2 bromobutane. So there in the structure there is a difference in position of substitution. So hence it is the positional isomers. Understood? Number 3.
Functional group isomer.
Yeah, functional isomers we can say instead, functional. Functional isomers. Okay, or we can say functional structural isomers. Okay, see, we have molecular formula the same, but difference in functional group. Suppose I am writing here CH3 CH2OH, so it is ethanol, but we can write with different functional group here the CH3O CH3. So this is the ether molecule, but both this compound have same molecular formula, but difference in their functional group. Here we have alcohol group and here we have ether group. Okay, so they are called as functional isomers. Understood everyone? You are getting the point now? Everyone do reply. Okay. See, here we have 2 carbon, so I'm writing here C2. Hydrogen we have 3, 2, 5, and here 1, 6. So C3H6 and 1 oxygen. So this is the molecular formula for both. Here we have 2 carbon, so C2, 3 and 3, 6 hydrogen. So here we have H6 and here we have 1 oxygen. So molecular formula is same for both, but they have difference in their functional group. Hence, it is again the structural isomers. So see, along by the type, I am making you understand with the help of example also. But when we will discuss all this in detailed form, I will write definition for them and with more example. Okay. Fourth one. What is fourth one? It is called as metamer. Okay. And last but not the least, we have tautomer. Okay, so these are nothing but different functional group. On the basis of different structure, we have 5 types of structural isomers, in which you gonna have all these 3, and these are not in your syllabus, but we will cover this also. Okay.
Okay, sir.
Yeah. So any idea about configurational and conformational isomers?
Yes, sir.
Yeah.
Optical and geometrical isomers.
No, I'm just asking difference between configurational and conformational isomers.
It differs in the configuration and the conformations of the specific molecules. Like, sir, in geometrical isomerism, there is 6 strands, so they have the same molecule and the same that IUPAC name, but they have the position is different.
And see, just do remember configurational and conformational isomers. Okay, these configurational isomers cannot be synthesized in laboratory. Can not be synthesized in laboratory. Okay, but conformational isomers can be synthesized in laboratory. On that basis, we have like different orientation in them. Okay, so here we have, there are 2 types. One is called geometrical isomers, and next we have optical isomers. So first we will cover what is optical isomers is. Okay, any idea about optical isomers?
Yes, sir. The optical activity in different compounds shows the optical isomerism.
Repeat again.
Yeah, if we pass the optical the light from if we pass light through a compound in a solution, then if the some configuration or conformation of the light changes, then we can say that it is an optical isomer. We can define it through this what you can say, the cis and trans and R and S configurations.
Okay, see, first we have to understand what is PPL. What is PPL? Any idea about
Parts per
PPL?
liter.
No. It is
what?
plain polarized light.
Oh, plain polarized, right? Okay. That I mean.
Polarized light. Everyone, are you there?
Yes, sir.
Okay.
Yes, sir.
See, suppose we are discussing about ordinary light ray. Ordinary light ray vibrates in all the possible plane like this. Is it? What is
Yes.
ordinary light? The light which vibrates in all the possible direction is called as ordinary light. Ordinary light. Okay. But when ordinary light ray passes through Nicol prism. Any idea about Nicol prism?
Yes, sir. It is a type of device or a prism which polarizes the light or into a same plane.
When two normal prisms joined base to base, as you can see here, and in order to join them, we are using Canada balsam. Canada balsam is nothing but a type of adhesive, okay, which is used to join these two normal prisms base to base, okay. Then the resultant prism is called as Nicol's prism. Okay, Nicol's prism. Understood what a Nicol prism is? These are the two normal prisms. They have joined base to base by using Canada balsam. Okay, that resultant prism is called as Nicol prism. Everyone understood that?
Yes.
Yes, sir.
Okay, so when ordinary light ray passes through Nicol prism, the emerging light ray vibrates only in one plane. Only in one plane. In any plane, I am just writing along with the vertical plane over here. Okay, so this light which vibrates only in single plane is called as plane polarized light, PPL. Understood what is PPL is?
Yes, sir.
The light ray which vibrates only along with the single plane is called as plane polarized light. And now we are going to understand about the optical isomers, because in order to understand that we had to learn that PPL is what. Okay, suppose here we have solution of three different compound. We don't know whether like they are optically active or not. Okay, so suppose this is the A. Here we have solution with A. Here we have the B, this is the B and this is the C. Okay, so when plane polarized light is passes through solution A, okay, so it changes its rotation, or it rotates the plane of the plane polarized light. Suppose it was like this, but it have changed like this. Okay, so see here, that solution have capacity to rotate the plane polarized light from, see, it was like this, but now it is like this, means it rotates in this way, clockwise direction, right? Is it or not? Do
Yes,
reply
sir.
everyone.
Yes.
Yeah, so the solution which have capacity to rotate the plane of plane
Yes,
polarized,
sir.
that compound or that solution is called as optically active compound.
Yeah, sir. I was also trying to say the same, but I was unable to express it properly.
Okay. Now we have another solution. Let it is B. Again, we have here the plane polarized light, and it rotates the plane of plane polarized into anti-clockwise direction like this. In this direction. So this is anti-clockwise direction. Okay. And in third case, suppose we have plane polarized over here and we are passing through the solution, but there is no change in plane. There is no change in plane of plane polarized light. So it is optically inactive. These are two are optically active. Okay. So now we are going to understand about optical isomers. Okay. See, optical isomers are arises due to difference in behavior towards the plane polarized light are called as optical isomers. Samar, what are optical isomers? Those
Yes,
compound, they have same molecular formula, same IUPAC name, but have different behavior towards the plane polarized light are called as optical isomers. Any doubt here in optical isomers?
no, sir.
I will give
No,
you
sir.
the notes also, don't worry.
No,
I will
sir.
explain you, I will give you the notes for that also. Okay. So those isomers, okay, they have same molecular formula, same IUPAC name, but the difference in behavior toward the plane polarized light are called as optical isomers. So we have better two types. We have two types. One is called dextro and other is called levo. Okay, so optical isomers which rotates the plane of plane polarized light into clockwise direction are called as dextro-rotatory optical isomers. And those compound, they have capacity to rotate the plane of plane polarized light into anti-clockwise direction. Here anti-clockwise direction are called as levo-rotatory isomers. Understood? So this is the dextro and levo. There are two types for optical isomers. Understood?
Yes, sir.
Yes.
Okay. Now we are going to understand about the geometrical isomers. Okay. Any
Sir,
idea
I
about
think it's time
geometrical?
for today actually.
This time
Uh,
is
yeah,
okay.
it is
Okay.
actually.
Let me explain you in short that
Yeah.
geometrical isomers. Okay. These geometrical isomers are arises due to restriction in rotation along with carbon-carbon double bond or triple bond. But we are going to understand only carbon-carbon double bond because for triple bond it is not possible for us to explain. Okay. So for triple bond, okay, we are not going to understand, we will understand with the help of double bond only. So again I am writing example here, it is CH3 CH double bond CH and CH3. Okay, so for that I am going to make you understand the two different structure. Okay, suppose here we have carbon carbon double bond, is it? So if we have carbon carbon double bond, so they are not going to rotate, and the position of one CH3 is over here, and here we have H. Okay, because that this H is also bonded with carbon atom, and here we have CH3 and here also we have H. So this is nothing but, okay, here same molecules or the group of same atoms or same group of atoms are present on the same plane. Is it or not?
Yes, sir.
Yeah, sir.
But
Yeah.
can we write that also here like CH3? Here we have C, here we have H, again double bond. Here we have C and H, and here we have CH3. So see here, this is the plane. So here we have same molecule or same group of molecule present on different plane. Is it? On first
Yeah.
case we have on same plane, but on second case we have the same group atom or same group of atom on different plane. So on that basis, we have two types of isomers and which are geometrical. The difference in their geometry. So if same atom or group of atom present on different plane are called as trans isomers. They are called as trans isomers. But when same atom or same group of atom present on different same plane are called as cis isomers. Okay, so if they are present on same plane, so they are cis. They are present on different planes, so they are trans. So on that basis, we had two types of geometrical isomers. Okay.
Okay, sir.
So today we have just gone through about the overview of the isomers. I think it will take one more lecture, okay, where I will give you the notes, we will write and we will have more example. Okay, so by next lecture we will start isomers from the beginning and we will complete in one lecture only. Where
Sir,
I
why
will
don't
give
we end the chapter of isomers here only? Actually, the whole chapter of organic chemistry we will study in this part only.
yes. So isomers
It
you
would
want to
rather be
study
better,
then-
like, because we have entered it already and good depth, so we can continue on it.
Okay, so you want to complete isomers first or
Yeah,
the chapter?
organic chemistry first. Yeah.
You want organic chemistry? Okay, we'll start organic chemistry. So on Monday onwards, we're gonna start organic chemistry first chapter. Okay.
Yes, sure.
Okay. So in isomers, any doubt? Because we will cover that in again chapter part again in detail one. I'll give you the note for that also. Any question, beta? Oh, 1 hour 19 minutes.
No, sir.
No, sir.
Okay, okay. So we'll meet in next class,
No,
beta.
sir.
Okay. Yeah. Okay. Bye bye. Good night,
Thank you,
everyone.
sir.
Yeah. Bye
Thank you,
bye.
sir.
Good.
Goodbye.
Welcome. Welcome.
Thank you, sir.
Welcome, beta.